Now, good morning. This is class 2 of our module 4 varying currents. Now, in the last class, we have studied about the growth and decay of current in an LR circuit, right? That is a circuit containing only the inductance L and the resistance R. Now, today we will learn about the growth and decay of current in a CR circuit, that is a circuit containing only capacitance C and resistance R. Okay, everything is similar. All the steps followed are similar to that we have studied in the last class. The only difference is that instead of inductance L, today we have capacitance C. Okay, now let us begin. So before studying this, you must understand what I have taught in the last class. Now today let us begin the growth and decay of charge in a capacitance resistance or CR circuit. Let us first discuss about the growth of charge. Okay, now this is a circuit. It has got a capacitor which is marked over here. This is the capacitor voltage VC, and this is applied EMF or the applied voltage. This is our resistance R, and this is the switch. Now when the switch is this is a two-way switch. Okay, when the circuit is closed, what happens? Charge will flow through the circuit. Naturally the capacitor will get charged. Now after a time t, when the charge on the capacitor, let the charge on the capacitor be represented by the letter small letter q, and let I be the charging current. Then the instantaneous voltage or potential difference across R is denoted as VR, because VR actually stands for the potential across R. It is given by IR. I is the charging current and R is the resistance. Similarly, the potential difference across the capacitance C is represented as VC equal to Q by C, where Q is the charge on the capacitor and C is the value of capacitance. Okay, now I already told that the capacitor voltage or VC is opposite to the applied EMF E. Therefore, the net potential difference. These sentences are similar to what we have learned in the last class. If you want, you can just compare and study. Okay, then the net potential difference across the resistance will be given by E minus Q by C, because this is a capacitor voltage Q by C. It is opposite to the applied EMF E. So what will be this here? E minus Q by C, that is equal to IR, that is potential across the resistance R. Now this I is again simplified or it is written of the form dq by dt, because we know that current I is actually nothing but the rate of change of charge with the rate of change of charge. Oh, okay, with the time. So I equal to dq by dt and R is kept as such. So from here you can find out the value of dt. Now you have to get the value of t. For that, what you have to do? You have to integrate this equation. So on integrating, we get this value, that is on integrating dt. Integral of dt is t is equal to, CR is kept as such, 1 by C minus Q. It will be log E C minus Q. Then there is a negative sign you can see there, and it is nothing but the negative that you see before this charge Q. Okay, that is written here, then plus a constant of integration. Now our next step, as that of last class, is to find out the value of this constant of integration C dash. For that we have to apply a condition. What is the condition? At time t equal to 0, q equal to 0. On applying this particular condition on this equation, you will get the value of C dash as this. Now you have to substitute this value of C dash in this equation. Therefore, the value of t will become like this. Okay, all these are very simple steps. So you just write it down, then you will understand. Okay, so finally you got the value of t. Now next is simple mathematics. Here which is common on the right hand side, CR is common. So CR on taking outside, and when you bring that CR to this side, it will become T by CR, and you are taking the negative sign also here, taking that outside. So that will be LHS will be minus T by CR, and so since this negative taken this side, what will be remaining here? Logarithm to the base c, c minus q, that is written here. Here we have already taken a negative sign outside, so this will be negative, because negative and negative will be positive, so you have to put a negative sign here. These are all very simple mathematics, you just write down, then only you will understand. Okay, minus log e c. So this is of the form log a minus log b. So what is log a minus log b? Log a by b. Okay, so this is log to the base e, c by q by c. Now on taking this exponential form, this log will disappear, so that's why you get e raised to minus, this side will become e raised to minus t by cr equal to, this log will not be written there, and so this one will be c by q by c, that is c by q, that is c e minus q by c, that is dividing each of this term, we are just splitting and writing, that is c e by c, this is equal to c e by c minus q by c. What is c by c? That is 1, that is why here 1 is written, minus q by c. Okay, then taking this one to the other side, that is q by c is taken to this side, so what will be remaining will be 1 minus e raised to minus t by cr. Again q is equal to c, you are taking to this side, so it will be c 1 minus e raised to minus t by cr. Then it is again simplified to q equal to q0 1 minus e raised to minus t by cr, that is your equation 1. What is q0? The maximum charge, that is instead of c we have replaced that c with the letter q0. So this is the equation governing the charging of capacitor, and this actually shows that charge on the capacitor grows exponentially. This equation shows that the charge on the capacitor, that is there is an exponential growth as shown in the figure given below. See, maximum value, it is the current is growing exponentially to the maximum limit q0 with respect to time. This is a charge on the capacitor. Okay, now next our aim, as discussed in last class, is to find out the capacitive time constant. Now the product cr is called capacitive time constant. It is denoted by the letter tau c. Okay, so now you have to put instead of t as cr in the above equation, that is, then what will be that equation will become equation 1. In place of t you are putting cr, so equation 1 will become q minus q is equal to q0 into 1 minus e raised to minus cr by cr, so e raised to minus 1, that is 1 by e. So equation will reduce to q equal to q0 into 1 minus 1 by e. See, okay, then this is again simplified to e value is 2.718. So on simplifying we get the value of q as 0.632 q0, that is capacitive time constant is the time in which charge on the capacitor grows from 0 to 0.632 of its maximum value. So study that definition also. With that we have ended the discussion about the growth of current. Now we will discuss about the decay of charge or decay of current in the circuit, in the same circuit. In the circuit diagram, now we are throwing the switch S over to B, so battery is cut off. Now what will happen to the capacitor? Then it will start discharging. So the decay equation will be of the form minus Q by C equal to IR. What is I? It is rewritten as dq by dt, that is rate of change of charge. With respect to time, R is kept as such. So from that, as discussed above, dt we have obtained, and then what is the next step? You have to find the time. So you have to integrate this. So integral dt will be t, and this also you have to integrate. So on integrating you will get t is equal to minus CR is kept as such. What is 1 by q? Integral of 1 by q, it will be logarithm to the base cq plus a constant of integration c dash, Then what is the next step? Everything is similar to what we have discussed. So to find C dash, you apply condition. Here the condition is different from that of charging. Here it is at t equal to 0, q equal to 0. On applying this particular condition, here you will get the value of C dash as this. Now put this value of C dash in this equation. So you will get the equation as t is equal to minus CR log to the base q plus CR log to the base q0. Again CR is common, you are taking it outside and bringing to this side, it will become T by CR, and negative also you are taking here, so that will come here. What is remaining is log to the base q, then negative negative positive, so negative here log it q0. So this is of the form log a minus log b, that is nothing but log a by b. So it will become log to the base q by q0. So this log, when it goes q, it will become q by 0, whereas this LHS will become e raised to minus t by CR. From that you just rearrange and you get the value of q as this. This is your equation 2. Now this is actually the equation governing discharging of capacitor. So which actually shows that charge on the capacitor decays exponentially. So charging as well as discharging of the capacitor in both cases is actually an exponential, that is exponential charging and exponential discharging. Here this is the exponential discharge. See, it is discharging from its maximum value q0. Okay. Now next step is to find the capacitive time constant. As discussed above, put instead of t in this equation 2, you are putting instead of t as CR. So what will be q? Q will be q equal to q0 e raised to minus CR by CR, that is nothing but e raised to minus 1. So q will be q0 1 by e, or q equal to q0 by e. See, it is written here. Value of E is 2.718. So you'll get finally the value of Q as 0.368 Q0. So this is the capacitive time constant, and it is defined as time in which charge decays from maximum to 0.368 of the maximum value. So that's all about the charging and discharging of current in a circuit containing only capacitance and resistance, or in a CR circuit. This is also very important. So you have to study both this charging and discharging of the growth and decay of current in LR circuit and CR circuit. Okay, or this they will ask questions from any of these two. Next is a few definitions, that is what is alternating current, what is alternating EMF, like that. Now a voltage that varies with the time is alternating voltage. Similarly, a current that varies with the time is alternating current. Now we always prefer AC voltage, AC current, everything like that. Why? Because it is very easy to convert them from one voltage or from one current to another by means of transformers. Also, it can also be transmitted over long distances. Now let us see the definition for an alternating current. Alternating current is one whose magnitude changes continuously with time. How it changes? Between 0 and a maximum value. And what about its direction? Its direction reverses periodically. So this is an important definition for an alternating current. Okay, this is the equation, a simple equation for an AC current, an alternating current, that is I equal to I0 sine omega t, where I0 is the current amplitude and omega is nothing but 2 pi by t, time period, or 2 pi f, frequency. So this omega is the angular frequency of alternating current. So this is the definition, and this is the expression for alternating current. And what is I0? Current amplitude. What is omega? Angular frequency. So this definition, the expression and the terms are important that you have to study. Now this is a graphical representation for an alternating current. See, the current is varying with the time. It increases, reaches a maximum value, and then it decreases, again it increases in the reverse direction, and finally reaches the limit. So this is of the sine wave. So this one actually forms one complete cycle. This is a complete cycle. See here the definition. The complete set of variation of current in one time period is called a cycle. Similarly, voltage whose magnitude changes from 0 to maximum value continuously with the time and whose direction reverses periodically is called alternating EMF. So here you have the definition for alternating EMF. Here we have studied the definition for alternating current. Okay, here current is varying with time, whereas here voltage is varying with time. So study these two definitions. Then what is a cycle? Just study this figure and the expression for alternating current, etc. Okay, then a few more definitions. What is amplitude? The maximum value of current in either direction is called amplitude or peak value of current. Okay, that is the maximum value. This is what, this is the peak value. This one is the maximum value in one direction. This is the maximum value in the opposite direction. That actually stands for the value of amplitude. Then what is time period? Time taken to complete one cycle of vibration. Okay, that is time period. Then frequency, it is a reverse of time period or the reciprocal of time period or the number of cycles completed in 1 second. That is the frequency. Okay, we know that for domestic applications or domestic appliances and all, the alternating current frequency is 50 hertz. That means that AC or alternating current in electric wires, bulbs, etc. flow 50 times in one direction and 50 times in opposite direction in 1 second. That is the word meaning of the term 50 hertz frequency. Okay. Now suppose that a bulb lights up 100 times and it is off 100 times in 1 second. Since in one cycle current becomes 0 twice. Okay, that is in 0 in one side, in that is in positive direction, and 0 in the opposite direction, that is in the negative direction. So but due to persistence of vision, we see for us it seems that the bulb is shining continuously. So here in today's class we have to study about both this growth and decay of current in CR circuit, definition for alternating current, definition for alternating EMF, definition for this one, what is a cycle, then the graphical representation of AC, what is amplitude, that is define amplitude, define time period, define frequency. Okay. So before going to studying this class, you have to learn the last class, that is class 1, which deals with the growth and decay of current in an LR circuit. Then only you will learn, you will understand the CR circuit, because everything is similar to that of an LR circuit. The only difference is that instead of inductance, as I told, here you have capacitance. Okay, so for today, this is enough. Thank you.